Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is IGCSE Physics, and we are doing its paper 4. This is theory paper, and this is extended physics. The code of this subject is 062425, and the paper we have selected is 4-2, and this paper 4 is from the zone 2, and this is May-June 2023. We have selected its question number 10. Why we are doing this question? Because this question is related with the space physics, and we are providing to our O-level students of the physics with the questions on the space physics. And so because we don't have that much questions in the O-levels on the space physics, that's why we are picking the questions from the IGCSE physics, and we are trying to provide them to our students all around the world who are preparing for the Cambridge O-level. So let's start. We are going to attempt question number 10 of this paper. So let's go to that question. So on your screen, question number 10 is showing up. This is May-June 2023 4-2 paper. Question number 10, A part. State the equation that defines the average orbital speed v of a planet. State the meaning of any symbols you use. You see, the orbital speed is, the formula for the orbital speed is 2 pi r divided by t, where the r is the radius of the orbit of that planet and t is the orbital period of that planet. So that's simple. Let me show you. Okay, so v is equals to 2 pi r divided by t, where the v is the orbital speed of the planet and r is the radius of the orbit of the planet and t is the orbital period of the planet. Orbital period means how much time it takes to complete one orbit around the sun. So v is equals to 2 pi r divided by t. So here, let me show you the marking scheme. Here you have the A parts marking scheme. Okay, so let's go to the B part. Question number 10 is B part. Suggest why countries that are a significant distance from the equator experience significant temperature variation throughout the year. You see, because when the Earth is spinning around its axis, it tilts. So the countries which are at a significant distance from the equator, so the angle at which the rays of the sun strike those countries or fall on those countries, that angle changes, it varies throughout the year. So this is one reason. The other reason is because the duration for which the sun is visible in those countries during the year, that time duration also changes. So these are the some reasons that why the temperature in those countries which are at a significant distance from the equator varies significantly. Countries that are significant distance from the equator receive sun rays at different angles throughout the year. Other than this, time duration for which these rays are received also varies throughout the year. So that's the one reason. So you can see question number 10, B part, its marking scheme is showing up on your screen. You can have a look at that marking scheme. Question number 10, it's C part. He says, fill in the gaps in the paragraph about a star much more massive than the sun. The stage that follows the stable state in the life cycle of a star is. So we are talking all about a massive star. So the stage which comes after its stable state in the life cycle of a star, which is massive, is the red supergiant. Red supergiant. If it explodes, so here you will write red supergiant stage. If then it then explodes as a supernova to form a nebula. So we will write here nebula. This leaves behind either a neutron star is formed or a black hole. So super red giant and nebula, here you write a neutron star or a black whole. So it's very important. I hope you have you remember the stages in the life of a massive star. So you can look at the marking scheme. Okay. So now we are going to the D part. Question number 10 is D part. It says a galaxy is moving away from the Earth with the speed of 33,000 kilometers per second. The value of the Hubble constant is 2.2 expo minus 18 per second. Calculate the distance from the galaxy to the Earth. Give your answer in light years. So the formula, you remember the formula is very simple. The speed is given 33,000 kilometers per second. I will convert it into meter per second. So for that purpose, I will multiply it with the 1,000. So now I have 33,000,000 meter per second. Then the Hubble constant is given here 2.2 expo minus 18 per second. The distance is given, but distance is questioned, but the distance we have to calculate is in the light year. The formula, the formula is the Hubble constant H naught is equals to the H naught is equals to V divided by D, where V is the speed and D is that distance. And because you want that distance in the light years, that's in 1 light year, remember, in 1 light year, there are 9.5 expo 15 meters. 9.5 expo 15 meter. That is equals to 1 light year. 1 light year means the distance traveled by the light in 1 year. So the D will be equals to the V divided by the H naught, which is the Hubble constant. V I will take in meter per second, that is 33,000,000 divided by. Now the Hubble constant is 2.2 expo minus 18. Another thing I will do, I will divide it with 9.5 expo 15 because because if you only take this thing, the distance will come in meters. But I want the answer in light years. That's why I will also divide it with the 9.5 expo 15. Why I'm doing this? Because I want the answer in light years. If I will not divide with this factor, then what will happen? My answer will be in meters. So that's why I'm dividing with the 9.5 expo 15 to convert it into light years. And so when you will do this in your calculator, and for example, you will write 33,000,000 divided by 2.2 expo minus 18 divided by 9.5 expo 15 equals to, you will get this answer. So I will convert this into the standard form. I will move this decimal here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will become 1.6 expo 9 expo 9. 1.6 expo 9 light years. 1.6 expo 9 years is the right answer. This is how you will do this question. So I hope you understand this question number 10 and it's a D part. And this formula is basically not in the O levels syllabus, but this is included in the IGCSE syllabus. So there is no harm in just understanding this. So thank you very much. We have done this video specially to provide questions to our O-level students related with the space physics. If you find this video interesting, if you find this video useful, if you find this video, if you think that this effort is useful, please share the link of this video with your class fellows, with your junior students, with your teachers, and all those people who are preparing for the upcoming exam of the Cambridge. And also, like this video, please subscribe to my channel. When you do this, this helps me to promote my channel. Also share the link of this video onto your WhatsApp groups, onto your Google Classrooms, onto your Facebook, onto your TikTok accounts, onto your X, Twitter, wherever you can post this, please post this. Thank you very much. I think it's a great blessing for me that I can make these videos who can touch the life of so many students, their parents, their teachers. Thank you very much. for watching this video. Have a good day. God bless you all.